Now that we've explored the theory of differentiation, let's have a look at some applications. To begin with, let's have a look at tangent lines and normal lines to curves. Let's begin by considering a point x equals a on a curve y equals f of x. Now, the tangent line to that point is the line which has the same slope as the function at that point. So if the slope of the function at x equals a is f prime of x, then the tangent line is a straight line with the same slope. How do we go about finding the equation of this line? Well, let's first consider the point here, which has coordinates a, f of a. Now the slope of this line is the same as the derivative at the point x equals a. So that equals f prime at a. Then I can use the straight line formula, which is y minus f of a, which is equal to the gradient times x minus a, which is f prime of a times x minus a. Or we can write this in the form y equals mx plus b, where m is just f prime of a and b is f of a minus a times f prime of a. If I now consider the angle here that the line makes with the x-axis, then the angle that it makes with the x-axis is just given by tan theta is equal to the change in y value of the change in x value of the straight line, which is the same as the change in y value over the change in x value at x equals a. So that is dy by dx at x equals a, which again is just f prime of a. The normal line is just a line which is perpendicular to the tangent line. So let me just do a rough sketch. So we had our tangent line and our function before, so y equals f of x. Our tangent line, the normal line makes a right angle with the tangent line, and so it's normal to the curve at the point x equals a. It makes an angle to the horizontal. If we know that our angle in here is theta, then the slope of this curve makes an angle which is tan of theta plus pi by 2, which is just minus cot theta. So therefore the slope of that line is equal to minus 1 over f prime at the function value a. And therefore the equation of this line, so that's an immediate application of the derivative. It lets us find tangent lines and normal lines to curves at a point. That's summarized here in this diagram. God, that was terrible.